This is from Semiconductors, NEST 2016, question number 8. Four ideal diodes are connected to form a circuit as shown in the figure. An AC signal Vin equal to 10 sine 100 pi t volts is applied across points 1 and 2, and the output is measured across points 5 and 6. The output voltage is 10 sine 100 pi t volts, 10 volts, 6.4 volts and 3.2 volts, and this is the figure. Let us now draw it in a slightly enlarged manner, okay, so that we can clearly show the current paths. Okay, now look, this 100 nanofarad capacitor is going to play the role of filter. It means, had that capacitor been absent, we would have got the voltage with roughly the same amplitude, that's 10 volts, but twice the frequency, twice the input frequency. And we have just now seen that in the theory, if it is a full wave rectifier, then the frequency doubles. Got it? The frequency doubles. But because of that capacitor, okay, that rectified voltage will kind of get filtered and it will fluctuate very slightly. Okay, something like this. Okay, so we will assume it to be a constant. Although the Zener diode requires it to be kind of strictly constant. Okay, and then we have got this load. Which is 33 kilo ohms. Now let us consider the rectification part. Suppose V1 is greater than V2. They are saying the voltage is being applied across points 1 and 2, so let's consider V1 greater than V2. So what is the possible path for the electric current? Okay, what is the path of the electric current? 1 to 3, this will be blocked. Okay, this will be blocked. So it will be, and of course capacitor is there, so it will flow through the load. Okay, it will flow through the load. Again, that's capacitor, so yeah, and then eventually it will return to 1 or 2. Okay, show it like this. Okay, so 1, 3, 5 to 6, 6 to 4, 10 to 2. Okay, now let us come to the other one, V1 less than V2 or V2 greater than V1. V2 greater than V1. Okay, now if V2 is greater than V1, then how will be the path? This path. Again through this, so it's 2 to 3, 3 to 5 and 5 to 6, and now we have understood that this is now a full wave rectifier. Okay, 5 to 6, and then we can take this. Okay, 2 to 1. Okay, so 2, 3, 5, 6, then 4, and then 1. Okay, so this basically tells us that the given design of diodes, okay, given design of diodes functions as a full wave rectifier. Have you understood this part? Or no? Okay, it functions as a full wave rectifier. Now there is something which we have not yet covered in the theory, but I'll tell you. V56 is the average voltage. Okay, V56 is the average voltage of the rectified voltage. Okay, so you have to remember this to solve the problem, because I said earlier that the capacitor acts as a filter and then it filters out the variations. Okay, well, most of them. So this is the input to capacitor filter. It filters out most of them. So we assume it to be a constant. Now, if you are happy with the formula, okay, if you are happy with the formula, then that V average is 2 by pi times V max. Okay, 2 by pi times V max, and that V max is 10. So it will be 2 by pi into 10 volts. So that's 20 by pi. That's approximately 6. Slightly less than that. Oh, sorry, greater than that. 6.36. Okay, 6.366. So that's option C. But now let me tell you how that 2 by pi comes. Okay, how that 2 by pi comes. Pay attention. Our V is 10 into sine of 100 pi t. What is omega? Omega is 100 pi. Okay, omega is 100 pi. What is time? Time period? It's 2 pi by omega. Okay, 2 pi by omega or 2 pi by 100 pi or 1 upon 50 seconds. So in 1 upon 50th, in a 50th of a second, the voltage is fluctuating or completing 1 cycle. Got it? But how about the output voltage or V rectified? V rectified has twice the frequency of input. Raise your hands if you understand this. Why? Because it is full wave rectifier. It's not half wave, it's full wave rectifier. Okay, so its frequency is twice the input. Okay, so if I were to find out, or if I were to find out the equation for the V rectified, what would it be? It would be 10 sine 200 pi t. Okay, raise your hands if you understand this. So what will be t here? It will be 1 upon 100th of a second. Got it? So if I want to now find out the average value, I must integrate V rectified from 0 to t, okay, 0 to t, and then I must divide it by the time period. Got it? And that's exactly what I'm going to do. If t is 1 upon 100, 1 upon t will be 100. 1 to 1 upon 100, sine of 200 pi t dt into, let's not forget that 10. Okay, let us not forget that 10. Now, I will deliberately keep this 10 as it is, and I will now ask you to calculate the integral with 100. It will turn out to be 2 by pi. Let's see. Let us see. Okay. What is the integral of sine? It's negative cos. Okay, it's negative cos. And most importantly, what are the limits? 0 and 1 upon 100. Okay, 0 and 1 upon 100, right? Yeah, 0 and 1 upon 100. And let's also not forget this 100. Okay? Okay. Wait, did I miss anything? Oh, yeah, my mistake. This is not 200 pi t, my bad. This is still 100 pi t. Let me tell you why. suppose this is the sine of it. Okay, this is just the sine. So for V rectified, see, because that can be negative. See, 10 into sine 100 pi t or 200 pi t, that could be negative, my bad. But you don't want it to be negative, you want its mod. Right, V rectified, we want its mod. Okay, we want its mod. So this will be flipped, this will be flipped. So let's only consider this part. Okay, so that t was right, my bad, t was right, 1 upon 50. Sorry, this was right, t is 1 upon 100, half of 1 upon 50, because this is 1 upon 50. But to find the average value over a cycle, we only want 1 upon 100. So that is right, 1 upon 100. The only thing is here we shouldn't have it as 200 pi t, because that is still allowing negative values. So that will give us 0. I just realized that. Okay, so this should be 100. Okay, this should be 100. Okay, now it is 100 pi t here. Okay, and then because of that integral, 100 pi will be in the denominator. 100 will get cancelled. So it's 1 upon pi with a minus sign. Cos of 100 pi into 1 upon 100, so that's minus 1, minus cos 0 is 1 into 10 into 10, so that's 2 pi pi into 10, and we already found it out. 2 pi pi into 10, that's 20 pi pi or 6.36. Okay, so the filter gives you the average of the peak, average of the input voltage, or the average of the rectified voltage. Have you understood this, or shall I explain it again? Because the average of that over a cycle will definitely be 0, right? We have seen that when we are discussing the AC alternating current circuits, AC circuits. Okay? So the correct option is C, 6.4 volts. Okay. There were two parts in the problem. First one was to recognize that it was the mechanism of the diodes was full wave rectifier, and then our capacitors role. Okay. Okay.